Today we're going to talk about section 6.4, which is all about exponential growth and decay functions. Okay, now the last 2 days we talked about exponential functions and we said that they are going to be in the form of f of x equals a times b to the x. Okay, well, we are basically continuing with that, but we're having specific examples now of when we have a growth versus when we have a decay. Okay, so let's take a look at the example that we have here. We have, and we're in our folder here, what is the account balance on $550 at a 4.5% interest rate compounded after 2 years? Okay, so first of all, let's talk about the difference between what we just wrote and what we talked about the last 2 days versus the formula that it gives us here. Okay, so the formula that it gives us here is a equals p times 1 plus r to the t. And I'm going to write the other formula that we had above it. F of x equals a times b to the t. Now, this is the same formula. I want us to understand this. It's the same formula. F of x is the same as a. Our little a, which was the initial value, is the same as the p, which is our principal amount, or how much we start with. B is our change factor, which is going to go with our r, which is going to be our percent increase. So we're going to deal with percent here. And then t and x go together. All right, so the first thing that we're going to do is we are going to write our growth slash decay formula. And then once we know what formula that we're using, and we'll talk about the difference between growth and decay with the formula here in a little bit, then we have to go through and actually find what is the important information from the problem. Okay, so we are going to label our values. And if we take a look here, we can see where the 550 comes from. That's the initial amount, the $550. We can see where the 2 comes from. That's the 2 years that we're going to leave the money in the account. Now, this number, 0.045, you can see is similar to the 4.5%, but it's different. And the reason why we don't write 4.5% is that we cannot use a percent, like the actual percent sign, in our formula. So we have to change it. We have to change 4.5% to a decimal. And we do that by dividing our percent by 100 or moving the decimal 2 to the left. And that's where the 0.045 comes from. Okay? So once we have those values, and we know which letters or which variables they go into, we just substitute. We're going to substitute into the formula, right? The 550 goes in where p is, the 0.045 goes in where r is, and the 2 goes in where t is. And then at this point, there's really not much for us to do here other than simplify the inside of the parentheses. And so I want us to understand that those are the same thing, right? We are simplifying there because you're going to see it written with when you've already added or subtracted, and you're going to see it separated out. Okay? So we are going to simplify and solve. And by solving, I mean let's type this into our calculator, let's type it into Desmos, and let's see what it gives us. And it gives us 600.61 or $600.61. Right? So this type of a situation, it's a bank situation of, hey, I'm giving the bank $550 to hang on to put into a bank account. The bank says, thank you for giving me your money. Now I'm going to give you money for letting me hold on to it. And that's where interest comes in. Okay, so it tells us what the interest rate is. So they multiply that amount by 4.5% over the course of the time of 2 years. And they say, hey, now after 2 years, that $550 grew to $600.61. Okay? All right, let's take a look in our books now. We are on page, I believe it's 128. Let's take a look at number 1. It says the population of Valleytown is $5,000 with an annual increase of 1,000. Can the expected population for Valleytown be modeled with an exponential growth function? Explain. So we can see there is an initial amount of people of 5,000 and an annual increase of 1,000. So we have the situation of we start with 5,000 after year 1, now we're at 6,000, year 2, 7,000, and you get what we're doing here. Now, the question says, can we model this with an exponential growth? And remember, growth is going to be P times 1 plus R to the T. So what we need in order for it to be growth, we need an R. We need a percent that it's increasing by. And nowhere in the problem does it say the word percent. Does it say the word rate? Does it give us a percentage? It does not tell us any of that. So we don't have an exponential here. What we do have is we're adding 1,000 every single time. So it ends up being linear because we have the same difference every single time. So what we can write here is we can say no, since the population grows by 1,000 each year, it is a linear function. Right? There is no percent increase. So yeah, we don't have an exponential growth. Okay? All right, let's look at number 3. Now, I don't have all of number 3 written down here, and that's okay, but we're going to talk about it. So with number 3, we have a video posted on the internet. It tells us how many views it has on the first day, which is 8,192 views. Okay, that's our principal amount. That's our P. Okay. It says that originally it decreases by 25% each day, and it gives us a function of f of x equals 8192 times 0.75 raised to the value of x. Now, one of the things that's very important here is, do we know where this number comes from? We have to be able to see that. So this number, the 0.75, if you read through the problem again, the problem says that it decreased by 25%. So they change that 25% to a decimal by dividing by 100 to get 0.25. And what they did is they did their subtraction now. Because it's a decrease, we are using the decay function, which has a minus sign inside here. So they're doing 1 minus 0.25. And that is where this number comes from. Okay, so we just have to be able to understand, like, where is that 0.75? They're subtracting 25% off. Okay? Now the question itself says, hey, what if instead of decreasing by 25%, we are decreasing by 20%. So our rate is different. Okay, so first of all, let's change 20% to a decimal, and we get 0.20. So our function is going to say 8192 times 1 minus 0.20 to the x, or f of x is 8192 times 0.80 to the x. This is the function we are going to evaluate, right? That's not our final answer, right? We need the function. Now, we can look at what does it want us to do with the function. And it says in how many days, and it tells us x is number of days, which means y has to be number of views. It says in how many days will the number of views per day be less than 1,000? So we are looking for what is x when y is at 1,000 or less. And this is where we're going to use Desmos in order to help us out. So if I go into Desmos and I'm just going to type in this exact formula or function that we had, 8192 times 0.8 raised to the x. Okay, now we can't see it here. There we go. All right. Now you can see it starts off really, really, really high here, and then it goes down, and then it flattens out. And because we are looking for when y is 1,000, what is x? Let's type y equals 1,000 in. I'm going to zoom out. I'm going to zoom up, and then here I can see where those two functions overlap. And it tells us when y is at 1,000 views, we're at 9.43 days. So basically, we have hit 9 days of the video, and on the 10th day, about halfway through the 10th day, our views start to go below 1,000 views per day. Okay? So we are going to say x is going to be 10 days, right? We're not going to say 9.43. We are going to say 10 days. All right. Let's flip to the next page. We are going to take a look at a couple of these other questions here. Let's look at number 5. We are writing our functions. So again, f of x equals p times either 1 plus or 1 minus r to the t, right? Plus if it is growth, minus if it is decay. So if we look at 5, it says an initial value of 100. So that's our p. We have an increasing. Increasing tells us it's growth, so we are adding. And at a rate of 5%, well, remember 5% divided by 100, that gives us 0.05 for our r. And then the only thing that we have to do is combine that 1 plus 0.05. So we have 100 times 1.05 to the x. If I do the same thing with 7, initial value of 512. So we have f of x equals 512. We are decreasing, so we are subtracting our rate. Our rate is 50%. 50% over 100, that's 0.50 for our rate. So we're subtracting 0.5, which means f of x is 512 times 0.5 to the x. Okay? All right. And then last one that we are going to do is question 9. It says, what is the difference in the value after 10 years of an initial investment of $2,000 at 5% annual interest when the interest is compounded quarterly rather than annually? So this is a situation where you are giving money to the bank and they are either going to take a look at that interest or add that interest in once in a year or 4 times in the year. Okay, because banks can do that. Different banks do that interest a little bit differently. So let's look at annually versus not annually. So with annually, we are actually using the exact same function we've used this whole time. Of a equals p times 1 plus r to the t. So if we plug our numbers in, we have an initial investment of $2,000. That's our A. We have a rate increase of 5%. That's our 0.05. And we have a time of 10 years. Okay, and I'm just going to leave this here. Actually, let's use Desmos and let's type this in. I'm going to type this in exactly as this looks. So we're going to do 2,000 times 1 plus 0.05 raised to the 10th power, and it gives us 3257.79, or $3,257.79. Okay, so that is $2,000 invested, 5% interest, 10 years, where the interest is calculated once a year. Now, if I do it not annually, we use a different formula. It's slightly different. We have A equals P times 1 plus. All of that is the same. But now, I have to take my rate and I have to divide it by the number of times that the interest is being calculated. So it's R over N. N is going to be the number of times that it is compounded. And then our time, we are actually going to multiply our time by that same number. Okay, so in our interest here, the one that we're doing, we are compounded quarterly. That means N is 4. Okay, so that means every 3 months or 4 times a year that interest gets compounded. So we have A equals the same 2,000 times 1 plus the same rate of 0.05, but now we're dividing that rate by 4. And our time, instead of it being 10 times that the interest is calculated, it's going to be 4 times per year. So 4 times 10 for the total length of time. Okay? And I'm going to type this in now. Okay? The only thing I'm going to do different is I'm going to actually multiply that 4 and 10 to give me 40. So if I do that, I'm going to type it in exactly as it looks, 2,000 parentheses, 1 plus, now I have the fraction, so I'm going to make sure I have that same fraction, 0.05 divided by 4, I have the same fraction, and now that is going to get raised to the 40th power, because it's 4 times per 10, for the entire year, 10 times 10 years. So that gives me 3287.24. So 3287.24. So we can see that compounding it quarterly, and again, this is, you're not touching this money, right? You're putting that $2,000 in, and you're just letting it sit there for 10 years. But if the bank compounds it once a year, you make this amount of money, right? You have this amount in your bank account. If they compound it 4 times a year, you make almost $30 more. Okay? So there's a little bit of a difference there, but again, you're not touching it. You're not adding any more money into it. Okay? So then when it says, what is the difference in there, we would just subtract these two values and say, well, that's the difference in compounding quarterly versus annually. Okay? So hopefully that helps. Again, I'm not too concerned about our compounding not annually, but compounding annually. This is the same function that we've been dealing with all of these, so this is definitely the function that we need to know for all of these situations, right? Is it a growth? Is it a decay? What's the initial? What's the rate? Do we change the rate the right way? So work through the homework 6-4. Remember, that is due Monday night. You will have time in class on Monday in order to do it, as well as get help from us. So if you have questions, please let me know. And have a wonderful weekend.